This video will discuss chapter 5-6, graphing inequalities in two variables. So the key thing with, or one of the key things with this chapter is remembering y equals mx plus b and how to draw, which is the equation for a line, and how to draw or graph a line. So the first thing I need to do is try to get this into y equals mx plus b, but keep in mind I won't necessarily have equals, I'm going to have this sign instead. So the first thing I would want to do is subtract 3x from both sides. Keep in mind the sign is coming down. This will cancel out. I'm left with negative y. Don't forget that there's a negative there. And then this is negative 3x plus 2. I'm intentionally writing it as negative 3x plus 2 and not 2 minus 3x because I want it to be mx plus b. Right? So I want the coefficient and the variable, the x variable, coming first. So after that, I need to get rid of this negative. Remember that there is a 1 here. Right? So I'm going to divide both sides by negative 1. Okay, now remember when I divide both sides by negative 1, I'm dividing everything by negative 1. Keep in mind that negative 1 is a negative number, meaning that this sign does flip. That cancels out, so I'm left with positive y. The sign has now flipped. Negative 3 divided by 3 is positive 3x. I'm sorry, negative 3 divided by negative 1 is positive 3x. And then 2 divided by negative 1 is negative 2. So this is now the equation that I'm going to graph. Okay, remember it's y equals mx plus b. So this is my slope. Okay, that's my m. And that's my b. All right, now we're going to take this onto graph paper. So again, here is the inequality that I'm going to graph. Remember that this is my b, which means I can come down to negative 2. Sorry, kind of off the screen. Come down to negative 2. I can put my first... That's my y-intercept. Then I'm going to use my slope, which is 3 over 1. So I'm going up 3, right, because this is rise over run. So I'm going to go up 3. That's 1, 2, 3, and over 1. That's here. Okay, and then from here I could go up 3, which will be 1, 2, 3. I kind of jumped an extra there, and then over 1, and that'll put me here. Okay, and then I can draw now this line. And so I want to make sure we understand the difference between dotted line and solid line. So a dotted line is similar to an open circle. It means it can't actually equal. So that would mean that it looks like this or this. Right? I'll show you what the closed line looks like next. So my dotted line should look something like this, right? Remember now this goes on forever. All right, so now the question is, which side am I shading? Because remember that unlike an equation, this means that there are a range of numbers that are true. So either all of the numbers on this side of the line will make this statement true, or all of the points on this side of the line will make this statement true. So the easiest way is to pick a point now that is on one of the sides of the line. And the easiest point, or most people will tell you the easiest point to pick is the origin, 0, 0. Okay, so I'm going to pick this point 0, 0 to try to figure out if 0, 0 makes this inequality true, I'm going to shade this half of the line. If 0, 0 does not make this inequality true, it means this side is not true, which means I would shade this side of the line. Okay, so I'm going to put a 0 in for y, and then a 0 in for x. 3 times 0 is 0, so it becomes 0 minus 2. Okay, and so I've got 0 is greater than negative 2. Now, I'm looking now at this statement, and I'm talking about this point here because I picked 0, 0. Right? And you could pick any point you want. I mean, you could pick a point over here, like 8, comma 4, and you would have to put 8 in here and 4 in here and figure out if it works. You just need a point that's on this side and a point that's on this side. Again, I picked 0, 0 because 0 is my favorite number, and because I can anything I multiply times 0 equals 0. So it's very easy to do a lot of math with 0 in my head. Looking now at this inequality, if this inequality is true, then the point 0, 0 should be shaded, and everything that is on the side of the line, the same side of the line as 0, 0 will be shaded. If this statement is false, then 0, 0 is not part of the solution set, meaning that I need to shade the other side. So since 0 is in fact greater than negative 2, I'm going to shade all of this. So all of the points on this side of the line will make this statement true. In fact, you can see that like if you were to go 0, 6, if I put a 0 in here, sorry, a 0 in here, and a 6 in here, this becomes -2 and this becomes 6, and 6 is in fact greater than -2, which is why that point would work. You know, and if you want to see one that doesn't work, pick one of these points. Like for example, this point, 2, 0. If you put a 2 in here for x, this becomes 6 minus 2 is 4. So 2, 0 means I put a 0 in here, put 2 in here and a 0 in here. This becomes 4 and this becomes 0, and 0 is in fact not greater than 4. Okay, and since 0 is not greater than 4, this point here is not part of the solution set, which is why it is not shaded. Okay, so remember what you're doing now is you're not only developing this line, but you're also figuring out which side should be shaded. All right, let's try another problem. Okay, looking at this particular problem. Again, we got to get to y equals mx plus b, so I need to move the x over to the other side. It's going to cancel out. I got 3y is greater than or equal to -2x plus 18. Remember, I'm intentionally not writing it as 18 minus 2x because I want it to be mx plus b. Okay, then what I'm going to do is divide the 3. Remember, I got to divide everything by 3. Since 3 is a positive number, I am not going to flip the sign. This is y. This becomes -2/3 x plus 6. So I got y is greater than or equal to -2/3 x plus 6. So now it's going to be this equation, or sorry, this inequality is the one that I'm going to graph. So here's my graph, and you can see that I have the, oh, I see, I skipped some numbers here. All right, so you can see that I have the inequality right here. So I'm going to go up to 6, which is here. Okay, and then I need to go down 2, so that's down 1, 2, and over 3, 1, 2, 3, should put me here. Right, down 2, over 3, would put me at 6, right? So 2, 6. Okay, so this now is going to be my line. You'll notice that I'm picking 3 points. You don't necessarily have to pick 3. You could just pick 2. Okay, but remember, I'm using my b to find the first point, and then I'm going down 2 over 3, down 2 over 3, and that's using rise and run. All right, so then, I'm going to get rid of those arrows because I'm going to do something else over there in just a second. Because if you remember, we just talked about how this gives us a dotted line. If it's greater than, less than or equal to, or greater than or equal to, it now becomes a solid line. So this line is going to be solid like this. All right, now again, I need to figure out which side of this line is going to be shaded. And so this point, again, is the easiest point for me to use, but you can use any point on the graph that you want. Okay, this way I can put a 0 in for y and a 0 in for x, so this becomes 0 is greater than or equal to, and then 0 times -2/3 is 0 plus 6. 0 is greater than or equal to 6. Okay, so if this statement is true, I'm going to shade all of the points that are on the same side as 0, 0, so that'd be all of these points. If the statement is false, I would need to shade all of these points. So 0 is not greater than or equal to 6, which means 0, 0 is not part of the solution set, so it's going to be on the opposite side of the line. So these are the points that I'm shading. All right, so a couple things to keep in mind is when is this line going to be solid and when is this line going to be dotted? Right, and again, that's because of this sign. If it's this sign, it's dotted. If it's this sign, it's solid. So a lot of times people remember it by that's the line. Okay? And then also using a point to figure out which sides should be shaded. So once you get the line, you're half done. Now you need to figure out which side to shade. And again, like I said, 0, 0 is a great point to choose because you basically put a 0 in for y because you've already done all of this work to isolate the y. So the y is always going to be by itself. So if I can pick a point where y is 0, I can just substitute a 0 in here. Okay? And then obviously, since it's mx, when I take whatever m is, whatever the slope is, times x, if x is 0, then this will always be 0. So this will be 0 and this will be 0 as long as I use the origin, which makes it very easy to get down to here. Right? So that's the key, is to kind of try to get there quickly, because then I just want to shade. Okay, I also want you to notice how the shading is not something where I'm spending 20 minutes coloring in this side. You know, just shade the side so that we know what should and should not be included in the solution set. All right, that's all we got for you in graphing inequalities in two variables. Keep in mind when you should use a dotted line, when you should use a solid line, and then how you're going to determine which side of that line you want to shade. Don't forget to do the problems at the bottom of the page. Thanks for watching the video. I'll see you in class.